Hey there, so we've got another video for you guys, and this week we're going to be talking about some updates to one of our tools, which is Cover. And we're going to talk about some of the current updates as well as some future updates. And we've got two of our software engineers here. We've got Anmol and we've got Owen, and we're going to have Anmol take it away and start us off with some current updates to Cover.
Yeah, so we made a number of improvements in the new version of Cover, specifically focusing on the performance aspects. Previously, Cover would only cover up to Java version 11, but in newer versions, we can cover up to Java version 16. The nice thing about this is if you have sub-libraries that your project is using that were built with the previous version of Cover, you do not need to recompile those libraries with the new version of Cover, so that saves a lot of adoption time or transition time to the new version. Another major change that we made is the probe injection strategy. So the probe injection is how we collect all the coverage information during runtime. Previously, we used to analyze the bytecode of the source code and then insert probes where to collect information. The drawback of this is when the compiler goes to build the project, there's certain optimizations that the compiler makes, which were not known to the probes prior to because they were inserted prior to the build. And so what that would result in is execution of code that the probe was not privy to. So we would have no coverage information on those chunks of the source code. The change that we made is now we analyze the source code itself to determine where to insert the probes, and they're inserted prior to the build. So now any compiler optimization or optimizations made by the compiler are carried forward since the probes were injected in the source code itself. This improves accuracy greatly. So now there will be no chunks of unknown coverage information like there were previously. And in fact, this is one of the highest accuracies of any tool for coverage. It's not a common feature. Additionally, now we're able to cover anonymous and lambda functions. Previously, it was difficult to inject probes for anonymous and lambda functions when it was made in the bytecode. But again, using the source code, we can insert the probes, which will be carried forward through the build and then collect coverage information for those functions. Another nice thing about this is even though the accuracy has increased greatly, the build time has not. So usually as the accuracy of the coverage information being collected increases, strong correlation is also the build time. So in our benchmarks, the build time for a standard program was 4.225 seconds. With the bytecode build, the build time would take 4.898 seconds. And with the source code coverage version, the build takes 4.972 seconds. So it's a very marginal increase, but a large increase in the accuracy. Another small thing that we've added in the new version of Cover is integration with our other tools. So Cover is generally used at system testing level. Another tool that we have is controller tester, which is used for unit and integration testing. One thing you can do now is if you have system tests that are ran with Cover, and you can find conditions that were missing in your system test, you can import those results into controller tester and write unit tests for those missing conditions. So this is a much more efficient way to achieve 100% coverage rather than either writing hundreds and hundreds and hundreds of unit tests to get 100% coverage at the unit test level, or writing duplicated or redundant system tests to get 100% coverage at the system level. So you can sort of leverage what both the testing techniques, I guess you could say, are good at to achieve 100% coverage. That's primarily all the performance improvements that we've made in the new version of Cover. There's also a number of UX improvements and changes that we're planning on making in the coming year, which I will hand off to Owen to cover.
Yeah, so in terms of the UX and the usability of the application, there's a new installation process. The installation process used to involve setting environment variables, configuring firewalls, setting ports, and that's all been simplified with the new installation process. In terms of security, the customer now has the option to implement a security policy, which involves password policies for strong passwords and account expiration after a set number of days. There's a new strategy for how the licensing will work. So the old way was to have one license for one server. And the problem with this was this had to account for high volume usage. So if you had one server, whether you were running a few files a day through it or a project with millions and millions of lines of code, it would be this one license still. In the new strategy, you pay for the number of cores that you're using. So if you have a small project, you have fewer cores, and the license will reflect that. So along with that new license strategy, there's been an added interface for monitoring the microservice connections and a license management page for managing the core licenses. In addition to that, there's been a large number of other UI and UX improvements to follow the SureSoft style guide and make the application easier to navigate. So that wraps it up for what improvements have been made so far.
Great. That's fantastic. Those are some pretty significant improvements. So what about some upcoming improvements? Can you talk a little bit about what's down the line, what's coming down the line for us?
So in the short term, one of the highest priority items is to support Python, which is the language with a very high market share at the moment, as well as adding Cover as a service. So right now, Cover is an application that's installed and ran independently of any other build or version control workflows. So the new way will be to integrate that directly into version control or the build process, which reduces onboarding time for setting up Cover with a new project, will improve the implementation time for executing the coverage calculations and analyzing the results. And additionally, allocating personal hardware won't be required. So in addition to this, a code review system is going to be added, which basically allows coverage results to be displayed during code reviews. So when new code is added before it's committed into the project, the reviewer can tell if that new code has been tested or not, which is extremely important when making changes to the code base. And coverage is overall more effective when it's implemented right in the change control system, because new code at that point won't be added at all unless it's been tested. In addition to that, enhanced embedded support is going to be added, which will easily apply to environments without a C++ compiler. So in an embedded environment, it's typically unusual for the compilation process to happen on the embedded system. So it will typically be compiled beforehand and then added to the embedded system. So that wraps it up for the short-term improvements. But for the long-term improvements, the main goal is to wrap up multiple development tools into a single build process. So the purpose of this is to take static and cover and to execute the build and analysis in one step instead of having a separate process for each tool. So what this is going to do is improve insight analysis. It's going to improve QA of the code, and it's going to save developers time and money with only having one build process. In addition to that, historical data for both tools will be integrated into one source, which will make it much easier to analyze the changes over time in the quality of the code.
All right, so that was a little update as to the performance improvements for Cover and some upcoming improvements as well. If you have any questions about any of these tools, anything that we're talking about here today, please be sure to get in touch with us and we'll be happy to help you out.